5.nf.2, my favorite. Actually, I'm just saying that, hoping that it's better than you think it's going to be. The learning target is adding and subtracting fractions with visual models. Now, before we even get started, let me just say that, and I'll say it again later, sometimes you're going to use the visual models to help you, and sometimes it's actually easier just to do the math problem. So anyway, vocabulary, you need to know what we're talking about when we say visual models. Visual model. Visual is something you can see. If you're goofing off and I wave my hand in the air and you see that, that's a visual cue. As opposed to if I yell, "Hey, be quiet," that's a verbal cue. Verbal is something you hear, but visual is something you see. Okay, anything you see. A model is also something that you usually see, but it's an object or a picture that represents something. So a model would be like a model car that you put together, or a model train, or like a model that wears clothes. That's something that shows you something. Okay, it represents something. All right, so let's move on. Notes. You can model fractions with a shape. That's a good way to model fractions, like a rectangle. A rectangle is probably the most popular shape. When you model fractions with a shape, the denominator is the number of sections in each whole rectangle. So if you look at the example here, that's an example of 1/4. There are 4 sections in the whole rectangle, and there's a number 4 in the denominator. So anytime that you're modeling fractions, you want to make sure you understand how the denominator works, what it means in that model. So, for example, you can model fractions with a number line, and in that case, the denominator is the number of sections between each whole number. So let's model 1/4 on the number line. The denominator is 4. There should be 4 sections between each whole number. So from 0 to 1, there's 1, 2, 3, 4. 1, 2, 3, 4 sections. Not little lines, but sections. Okay? Once again, 1, 2, 3. There are 4 sections, and if you just move one of them, then you're at 1/4. All right. So, sometimes a model helps to answer the problem, but sometimes it's easier to use numbers. Just keep that in mind, especially as you're doing your homework assignment today. All right, example. We're going to show 3/4 minus 1/6 on a number line and using a rectangle. So let's start on the number line. When you are dealing with fractions that have different denominators like these, you're going to want to find a common denominator, find your equivalent fractions first, and then use your number line. So the common denominator for 4 and 6 would be 12. So I'm going to change 3/4 into 12ths. That's a hard one for me to say. And 1/6 into, 1/6 into 12ths. All right. So 3/4, I'm going to multiply by 3 and by 3, and I'm going to get 9/12. Whew, my penmanship is something else. 1/6, I'm going to multiply by 2 and get 2/12. Okay, so now I can show this on a number line, and I already have my number line set up with 12 sections between 0 and 1 because I knew I was going to have to use 12ths. That's the thing about using the number line. You can't just mark 4 sections and then 6 sections because of the 4 and the 6 right there and there. You've got to get a common denominator. Anyway, so let's start with our first number, 3/4, which we turned into 9/12. So find 9/12 on the number line. 1, 2, 3, 4, 5, 6, 7, 8, 9/12 would be right here. And we're going to subtract 1/6, but 1/6 was equal to 2/12. So we're going to subtract 2. 1, 2. We're going to move 2 to the left because subtracting means making it smaller, going closer to 0. So when I subtract 2, I get back to this spot, which is at 7/12. So I subtracted 1/6, which we know is actually equal to 2/12. So our answer is 7/12. We can show that using a rectangle also. So if we slide over here, let's just remember what our fractions are. 3/4 is equal to 9/12. So I made 12 boxes. Remember, use the common denominator to figure out how many total pieces there should be in the whole. Now I need to shade in 9 of those because 3/4 is 9/12. So here is 3/4. And now we're going to subtract 1/6. Remember, it's 3/4 minus 1/6, which we found out earlier is the same as 9/12 minus 2/12. So we're going to subtract 2/12. The way you can subtract on this area, on this model here, is just by xing those out. We xed out 2 of the 12ths. And what we're left with is 1, 2, 3, 4, 5, 6, 7. We're left with 7/12. All right. Moving on. We're going to show addition. 3/4 plus 1/6. Fortunately, we already know what those equal in twelfths. So 3/4 is 9/12. So I'm going to go right to 9/12. I know that 1/2 is 6/12. So I'm going to start at 6. 7, 8, 9. So there's my 9/12. There's my 3/4, which is the same as 9/12. I'm going to add 1/6, which is the same as 2/12. So I'm going to move 2 more to the right because adding makes a number bigger. And when I add those 2 spaces to the right, I'm adding 1/6, and that would make a final answer of how many twelfths? Well, let's take a look. Use my highlighter. Starting at 0, 1, 2, 3, 4, 5, 6/12, 7/12, 8/12, 9, 10, 11/12. So my final answer is going to be 11/12. 3/4 plus 1/6 is 11/12. On the rectangle, 3/4 plus 1/6 is the same as 9/12 plus 2/12. So 9/12 is 9 boxes plus 2 more. That makes 11/12. Okay. So that's modeling using each of the types of models that we're using today. Okay, so here's some extra examples. Do not write these down, just pay close attention to them. So Evan swam 6/7 of a mile and ran 1/7 of a mile. Which model can be used to find the total distance? Total distance means you are adding them together. So you got to see the clues in the problem. So, which model is going to start by showing 6/7? Well, I'll tell you what, it is not this one. That's 7/7. So that doesn't make sense. So we're looking for 6/7 minus or plus 1/7. 6/7. There are 7 in each of these whole rectangles. So the ones that show 6/7 are this one and this one. Not this one or the other one that I crossed out. So which one shows adding 1/7? Because we're finding a total. It's the bottom choice. Got it. That's the model. Next problem. Use the information from part 1. What is the total distance that Evan swam and ran? Well, the total distance, 6/7 plus 1/7. if I put the 1/7 right there, that's going to make a whole rectangle. So 6/7 plus 1/7 is equal to 7/7, which is equal to 1 whole. So it would actually look like one of these rectangles all the way shaded in. So he ran 1 mile. Got it? Okay, next one. Which of these scenarios can be represented by the picture? Well, that picture has 4 sections. That means that the denominator is 4. 3 of them are shaded in red, but then we're crossing out 2 of them. So we're taking away 2 of the fourths. So which scenarios can be represented by the picture? Select all that apply. Difference means subtract. So this is the difference of 3/4 and 2/4. Now look, they're trying to trick you. 1/2, if we're talking about fourths, how many fourths are in 1/2? I'm going to make an equivalent fraction and find out that that's the same as 2/4. So it is the difference of 3/4 and 1/2, because this 1/2 is the same as, or this 2/4 is the same as 1/2. So it is. It is also the difference of 3/4 and 2/4, because 2/4 is equal to 1/2. All right. Valerie has 3/4 of a yard of fabric and she cuts off 1/2. So she starts with 3/4 and takes away 1/2. That's what we're talking about. Okay, that's exactly what we had drawn. Reshma has 3/4 and she gets 2/4 of a cup more. I'm looking at this bottom one here. If she gets 2/4 of a cup more, that's addition. She's adding. So that is not a correct answer. Okay, last question. It is 2 3/4 miles from Nadine's house to her school, and it's 1 5/8 miles from Nadine's house to the store. Use the number line below to find out how much farther it is from Nadine's house to the school than from her house to the store. That is a subtraction problem. We've got to put both of those numbers on the number line. Man, this video is taking a long time. All right, so you can see that the number line has numbers that are in eighths. So I'm going to turn both of these fractions and both of the mixed numbers into eighths. So 2 3/4 equals how many eighths? I'm going to multiply by 2 over 2 to get my equivalent fraction. So it's equal to 2 6/8. And the other number, 1 5/8, I'm going to turn 5/8 into eighths, which it already is. Okay, so both of these are in eighths. I can look on the number line. So 2 6/8 would be, let's make it bigger. 2 6/8 would be right here. Here's 2 4/8, 5/8, 6/8. Can I get any bigger? Nope. 2 6/8 is going to be right there. Okay. And 1 5/8 would be right there. So how far is that? That is the question, right? How much farther is it from Nadine's house to school than from her house to the store? We're trying to find how much farther is it from that number to that number. So it is 1, 2, 3, 4, 5, 6, 7, 8, 9 eighths. 9 eighths farther. So our answer could be 9 eighths. Or we could turn that into a mixed number, 1 1/8. So that's using the model to answer that question. Your turn. Time to do a quick check. Show 2/3 minus 1/2 on either a number line or using a rectangle. And give the answer. Make sure you give me the answer. Good luck.